Hello, this is video number 10, and this is chapter 3, section 3. And this is all about solving a quadratic using the quadratic equation. Sometimes you'll hear that referred to as the quadratic formula. Those words are interchangeable, essentially. All right, so you guys have an extra credit opportunity every time you do a video and do notes by turning those things in on the day of the note day. Well, here's another chance for you to earn some extra credit. I have a song for the quadratic equation. So to earn some extra credit, and there is a day on your calendar. I don't off the top of my head know what it is. My dogs are making a lot of noise. They need to be quiet. The extra credit opportunity is to sing the quadratic formula. Here are the rules that these go by. You must stand to sing the quadratic formula. You must do it alone. You may bring an instrument if you want. I have had people do that in the past. I had a girl play the ukulele one time, and somebody else played the guitar. So it's up to you. And you must not have any kind of reference material in front of you. So it must be memorized. Okay. I don't care if you stand and face a wall if you don't want to look at everybody and you're worried about people staring at you. But this is how this is going to work. So you can earn 20 extra credit points for standing and singing the quadratic formula. And this is how it's going to go. It goes to the tune of Pop Goes the Weasel. Weasel, which is also, those like Jack in the Box things with those scary little clowns that jump out. Dun da dun da 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 dun dun da dun da dun dun. All right, that's the tune. So here's how it goes, and I'm gonna write it as I sing it, and I'll do this a couple times for you, and then I will prompt us to all sing it together in class, and then we'll do that a couple times. And then whenever we have our day for extra credit, you can stand up and earn your extra credit points. So here is the quadratic formula to song. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, ready? Now I'm going to highlight as we do it again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, now I'm on camera. You can you can go back and rewind, practice, do it in the shower, sound goofy like a total math geek. It's all whatever. But extra credit points. And this is handy when you do if you go on to do a bunch of college math, if you take your SATs, ACTs, you guys can't have reference materials for those. So I let you use your notes. So is it important that you have it memorized? Not really for my class, but it will come handily into play if you go on somewhere else. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Learn it, know it, memorize it. All right, here's how we're going to make it work for us. We are going to solve. Let's see. We'll start with one not turned over into weird places. 2x squared plus 12x minus 110 equals 0. All right, so maybe you could factor this, maybe not. Some of you don't like to factor. So this is something you could utilize all of the time. Now, keep in mind that this is in ax squared plus bx plus c form. And so our a is 2. Remember that you have to take signs with the numbers if they come before them. So b is 12 and c is negative 110. And then we're going to fill some things in. So x equals negative b, or b is positive, so it's going to be a negative 12, plus or minus. You need to keep both those signs in there. Make a big square root sign. and then 12 squared minus 4, parenthesis, a is 2, parenthesis, c is negative 110, all over 2a, so that's 2 times 2. All right, what I like to do, I like to put those in there like that. So the b I'm showing is squared, and then each of the numbers. Don't just stick all this in a calculator and get a value. That is impossible for me to try to figure out where you went wrong. I need to know what you're plugging in. So do that slowly and carefully and show your work. And then right above the radical, I like to evaluate these. So I'm going to go 12 squared is 144. And then I have a negative 4 times 2 times a negative 110. So remember, this is all multiplied. So I have two negatives, so it's going to be a plus, and that works out to be an 880. And then in my next step, I'm going to have negative 12 plus or minus 144 plus 880 is 1024. And that's over 2a, or 2 times 2, which is 4. Now, every single time you do one of these problems, you need to try to evaluate that radical or simplify it if possible. So this needs to get simplified. Meaning, is it a perfect square? If it is, that's great. This one is. And it allows us to just replace that with a number. If it's not, then you need to simplify that radical. Then simplify radical. Meaning, if you have something like, I'll just throw a rad 20 in there, you're going to make this a 4 and a 5, which is going to be a 2 rad 5, right? So that's the idea of what I'm talking about. This one is a perfect square. If you put the root of 1024 in your calculator, you're going to get a 32. So you have negative 12 plus or minus 32 over 4. And now when you get to this point, you have two answers here. And I like to just draw those branches off of there. And these come from this sign right here, this plus or minus. What's going to happen, I'm going to use the negative 12. And then I'm going to use the top sign, which is the plus. So I'm going to go plus 32 and divide it by 4. That's one of my answers, which we'll simplify in a minute. Then I'm going to go back and start with the negative 12 again. Now I'm going to use the bottom sign, the minus here, subtract off 32 and divide by 4. And now simplify these guys. So let's see. Negative 12 plus 32 is 20 over 4, which equals 5. So that's one answer. And negative 12 minus 32 is a negative 44 over 4, which is a negative 11. So your two answers for this are 5 and negative 11. And just so you know, that means if we were actually graphing this thing, you'd have a 1, 2, 3, 4, 5. You'd have a dot on negative or positive 5 on the x-axis, and one way out here at negative 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. At this point, you don't know where the vertex is, where it changes direction, but this is where this thing is going to cross the x-axis if you were to graph it, and we will be graphing later on. So just so you kind of have a picture in your head of what's happening. All right, now there's lots of things that can happen the way your answer can look when you solve a quadratic equation. So I'm going to go through a couple of those so you know how to deal with the simplification process. But there's a lot of places for you to make boo-boos. So you need to be very, very careful when you solve these problems. All right, also in varsity, they don't always put these in ax squared plus bx plus c form. They look something like this. It'll say solve x squared equals 12x minus 23. Well, make sure that you put this in standard form before you do anything. Remember, standard form is ax squared plus bx plus c equals 0. So we got to move both of these terms to the other side by adding or subtracting, opposite of whatever they currently are. So we're going to get x squared minus 12x plus 23 equals 0. And this one, it's really easy to see that you can't factor because 23 is a prime number, right? There's nothing that's going to multiply to 23 that's going to add to 12. And so quadratic formula is a really good way to solve these when you don't have something you can factor. So I'm going to start by writing my quadratic equation every time, and you have to listen to me sing. Sing with me. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, then I'm going to write down that a is 1, b is negative 12, and c is 23, and then fill those into my quadratic formula. So be careful here because the formula has a negative b in it, but now b actually is negative. And remember, minus a negative is a positive. So I have x equals, I'm not going to expect that you write this way, but minus a negative 12. I would just put a 12 in there. But for those of you that need to see that step, I want to include it. And then I'm going to go negative 12 squared minus 4 times 1 times 23 all over 2 times a, which is 1. All right, and then up above the radical, 12 squared is 144. If you put negative 12 and square it in your calculator without parentheses, and you get a negative, you should know better. Any number squared is never a negative. So make sure you're never getting a negative for that leading number right there. And then 4 times 1 times 23 is, oh, I did this somewhere, 92. All right, so we're going to go 144 minus 92. So we're going to get 12 plus or minus the root of 52. That's not 52. There's a boo-boo somewhere. I need a calculator. Oh, you can't subtract. Oh, yes, I can. That can be right. 52. I was thinking that was a whole number. Never mind. Ignore that. Okay, so this is an example where this is not a perfect square. So you must simplify this radical. And if we take the root of 52, that breaks down into, let's see, 4 and 13. The root of 4 is 2. So this is 2 rad 13 replaces the root of 52. So this is very different at this point from what happened in the last equation. So now we have x equals 12 plus or minus 2 rad 13 over 2. And then if you are able to divide all three of these coefficients or these whole numbers evenly by the same number, and you can see they all divide by 2, then you can reduce by dividing that number out. Common factor. You will never, you don't care about what's in the radical. This you don't need to worry about. Okay, but every single number that is in here needs to be divisible by the same value. If one is not divisible, you can't reduce any of it. So we're going to divide these by 2. So the 12 is going to become a 6. This 2 will become a 1. This 2 will become a 1. And some of these are unnecessary. So I have x equals 6 plus or minus 1 rad 13 is the same as rad 13. You don't need that 1 in front. And I don't need 1 if it's in a denominator because anything over 1 is what you started with. So the answers here are, here's my two answers, 6 plus rad 13 and 6 minus rad 13 because of this plus or minus in the middle. And you can quite literally just leave your answer like this. The only time we care about breaking them out is if we need to find the decimal value to plot these. Because you can plug that into a calculator and get the equivalent of those. Okay, so if we were graphing, we would need to know about what those were, but we do not need those. So this is your answer. X equals 6 plus or minus rad 13. All right, let's take a look at one that has an imaginary solution. So we're going to solve 6x squared minus 4x plus 2 equals 0. Here's our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we know that a is 6, b is negative 4, c is 2. So let's fill those in. Negative b is going to be just plain 4, right? Because it's minus a negative. Plus or minus the root of negative 4 squared minus 4 times 6 times 2. All over 2 times 6. Okay, simplifying in the radical. 4 squared, 16. And then I get a 24 times 2 is 48. So 16 minus 48. And that's going to give us that negative number underneath the radical. And we're going to get a negative 32 under there over 12. All right, well, recall that if you have a negative under a radical, this becomes an I. And then we just reduce the root of 32 like you would reduce any radical. So that breaks into a 16 and a 2. Root of 16 is 4. So the rad is going to turn into a 4i radical 2. We're going to replace that in the formula. So x equals 4 plus or minus 4i radical 2 all over 12. And here's another place where I can reduce all of those coefficients, the 4 on the I, and the 12 underneath. All are divisible by 4. And so I'm going to, that'll become a 1, that'll become a 1, this will become a 3. One of those ones is not needed. This guy is out in front because it's 1 plus or minus some value. So that's a constant, definitely need it. The 1 on the I, however, is not needed, right? That's like 1x. You don't need to put the 1 on the x or the 1 on the I. So this is just plus or minus I radical 2 all over 3. And this would be the answer to that question for you. All right, I think I have one more on the back. Let me see if they're actually needed. They all kind of have different issues with them. I don't think they are. Oh, this one might be. All right, let's do this one. This one's pretty quick. I just want you to see what's going to happen if b is 0. So if you solve this guy, it's going to look like 3m squared plus 2 equals 0. Well, here our a is 3. Our b is missing, so it's 0. And our c is 2. So we take our quadratic equation, x equals negative b plus or minus the square root, b squared minus 4ac all over 2a. And let's plug stuff in. So we have x equals negative b. Well, b is 0. Positive, negative, 0 is neutral, right? So it doesn't matter what's on there. But do plug these in just so you see what they're going to look like. 4 times a times c all over 2 times a. All right, so 0 squared is 0. And then up here we get, let's see, 4 times 3 is 12, times 2 is 24, so that's a negative 24. And the 0 out front is going to just drop off because that becomes unnecessary. So we have x equals plus or minus the root of negative 24 over 6. So we know that this is going to be plus or minus I rad 24 over 6. 24 is going to reduce into rad 4, rad 6. The rad 4 becomes a 2, so we get plus or minus 2i radical 6 over 6. And then these guys will reduce into a 1/3. So you have plus or minus I rad 6 over 3. Okay. And that's how you end up with, excuse me, either imaginary or just one solution sometimes. So that's what that will look like if you have 0 for a term. You're just going to still plug it in the way that you normally would. And none of these actually worked out this way, but here's another thing that could happen. If your a is negative, then when you plug into the quadratic formula, x equals negative b plus or minus the root of b squared minus 4ac all over 2a. If your a is negative, then this whole denominator is going to end up being negative. So you might end up with something like this. X equals, I don't know, let's say 4 plus or minus, I'm just making stuff up here, rad 5 over negative 6. You cannot leave this negative in the bottom. Cannot leave the denominator negative. So what happens essentially is you're going to change this to a positive, and that's going to change the sign here. And essentially it changes these signs also. So the plus becomes a minus and the minus becomes a plus, which still leaves you a plus or minus. So make sure that you change the sign on the leading term and change the denominator. So this answer would actually look like negative 4 plus or minus 2 rad 5 over a positive 6. Okay, don't leave that. That didn't happen in any of my examples, but we needed to make sure you know how to deal with it if it does. All right, so you currently have 2 ways to solve two methods to solve a quadratic. The first of those is by factoring with X method. And the second is quadratic formula. And we're going to be doing a third. We haven't done it yet, but the third is called completing the square. And numbers 2 and 3 can be done for every single equation all the time. Some of you are really going to like completing the square. Some of you are going to hate it. So you might decide, oh, I'm going to use quadratic formula every time because I prefer that, or vice versa. Me, I like to factor. So if I can factor, I'm going to do that all the time. And then I would go to, it depends on the problem, completing the square or quadratic formula. Sometimes completing the square can be a little bit yucky because it generates fractions. So if that's not going to happen, I prefer that over quadratic formula. All right, so this was chapter 3, section 3. It's solving a quadratic using the quadratic formula. We're going to have definitely a worksheet and a varsity, and don't be frustrated if you make some sign errors. It happens. There's a lot of places for signs to get bungled up when you do this. So be careful, be complete, and have some grit and get through it and fix your boo-boos. All right, toodaloo.